Hello, everyone. I hope you guys aren't as sleepy as I am. It is past my bedtime. So, I did micro contact printing at the University of Houston, and I'm from Montrose, Colorado, which I guess. Oh, there we go. Okay. So, unfortunately, I cannot take my room with me to decorate my dorm, but this was the layout of the dorms in Houston. We got to stay at them. So, there's my living situation. And then kind of an overview of what micro contact printing is. So I did 7, I want to say simple, but they were very frustrating steps. The first step is taking a coupling agent, which is silane, and applying that to a substrate, which I worked with glass. And then you make a PDMS stamp, which is like your relief pattern. You cure the stamp. You apply agadecane which is ODT. You press that ODT onto the gold for a fixed amount of time, and then you remove the stamp from the gold, and then etch the bare gold away. So the first step is applying the silane. So I took a pipette and I put a fixed amount of drops in a little petri dish, and then I put my glass substrate in another petri dish, and I put that in a vacuum desiccator. And what the vacuum desiccator does is it vaporizes the silane, it forms a monolayer, it prevents the PDMS stamp from adhering to the substrate, and it controls surface energy, which is like hydrophobicity, stuff like that. The next step is measuring and computing contact angles of the silane film. So what I would do is I would take a little droplet of water and put that on my substrate, and then I would take the contact angle of that water droplet. And the graph above shows those contact angles for a fixed amount of drops from 0 to 10. There's a steady increase until it starts to level out to 7 to 10. The blue bars represent oven-baked glass, which is basically when Si and Co bonds turned into Si and OH bonds, and then they bond to the surface of OH. When it is heated, those OH bonds turn into oxygen and water, which makes it harder for the Si and OH bonds to bond to the surface. And then making the PDMS stamp, you would mix a 5 milliliter of elastomer base to a 0.5 milliliter of curing agent, and you would pour that over the glass substrate, and you would cure it under certain circumstances until you would get something that looks like this. These are all my failed attempts. I have another failed attempt that I got too frustrated to even take a picture of, so I didn't. The second image you see there, it's perfect, but I forgot to put the glass substrate in. So I think I was too worried about eating lunch in an hour. So, anyways, after that, I would douse the stamp in agadecane and then stamp that onto gold for a fixed amount of time. The agadecane forms self-assembled monolayers on the surface, and then those control the resistance to corrosion, which is etching. So for etching, I would immerse the gold after it was stamped in KCN and KOH, and I got what kind of looked like that. So on the right side is, on the right side is the etch gold, and on the left side is the stamped side, so you can kind of see a difference there. And the stamped side, it was very hydrophobic with high contact angles, and on the right side, it was hydrophilic with low contact angles. So it's cool to see that difference there. And then after this, I decided to do a little experimenting with heat. So after 14 minutes, this is what I got. Then after 31 minutes, that is what I got. The image on the left, right here, that was after 40 minutes, and then the image on the right was kept at a lower heat temperature, and that was for an hour and 13 minutes. So applying heat significantly changed the etching. surprising things I learned. So micro contact printing, even though I only got to work with glass, it can be applied to a variety of different things, like you can see in this image. But one of the coolest things that I learned was that it can transfer proteins, polymers, nanoparticles, and it's used for like electroplating, electrolysis plating, which is like your jewelry or screws. And it's also for analyzing antigen-antibody interactions, which is between DNA and RNA. Outside of research, like Joseph said, we went bowling a lot because that was about the only thing we could do. We did get to go to an orchestra concert, which I've never been to one, so that was pretty cool. The squirrels there were so nice. They would chase you around the campus begging for food. This is one of the squirrels that I fed my brownie to. And then the snail in the little corner, I named him Burl after the hurricane, and he kept me company. I would say that I was not expecting to encounter a hurricane, and I was definitely not expecting to get a last flush from other dorm rooms. And then thank you to everyone who supplied this.